System of equations is something like this, where you have multiple equations and you're solving for both the x and the y. When solving a system of equations, you can either graph them and look to see where your two lines cross, or you can solve them using substitution or elimination with addition. Let's start with graphing. Example 1, graphically solve 3x plus 2y equals 9 and y equals 5x minus 2. All right, let's first rewrite this first equation, the 3x plus 2y equals 9, in the form y equals mx plus b. So I'm going to subtract my 3x over to the other side and then divide by 2. Okay, this one's going to be kind of tricky because we are graphing fractions, but we can totally do it. All right, let's graph this. Remember, the b part is your y-intercept. So 9 halves is 1, 2, 3, 4, 5, 6, 7, 8. 9 halves is 4.5. And negative 3 over 2 means I have to go down 3 and forward 2. Down 3 and forward 2. And then you would connect the dots to make that as smooth of a line as possible. When you're solving graphically, you want to make sure you are super clear and straight. And I don't like solving graphically because I think I graph very messily, and that's not a good thing when you're solving graphically. All right, my second equation is y equals 5x minus 2. So we have our y-intercept here, negative 2, and it's 5x, or 5 over 1, so I need to go up 5 and forward 1. And up 5 again and forward 1 again if you could. I am going to now connect the dots. And they cross right here. So my solution is the coordinate point 1, 3. Solving graphically is really hard to make sure you have everything crossing perfectly, because what if your answer ends up not even being whole numbers like that? So that's kind of a last resort, but it's good to know that it exists. Okay, so how do you use algebra here and actually solve it without a graph? We're going to solve these first two using substitution. And so you can use substitution on every single example, and you can use elimination with addition on every single answer. I like to switch back and forth depending on the setup of the original equation, but if you want to just stick with one method and solve every single problem that way, then go for it. So let's start. We're going to do two examples of substitution. So in order to solve a system using substitution, first you want to solve one equation in terms of one of the variables. Luckily, we already have that in this example. It's already written y equals or x equals is also okay. Step 2, replace that variable in the other equation with the function found in step 1. So replace the y here with all of this. Step 3, now you're going to solve. Once I fill this in, 5x minus 2 for my y, I'm going to solve all of this for x. And then once I know what x is, I can sub it back into the second equation to figure out what y is. So let's do that now. So step 1 was already done for us. We already have it y equals 5x minus 2, so I already have y equals. Step 2, plug this 5x minus 2 in, or substitute that 5x minus 2 in for y in your first equation. Don't forget you still have your 2 on the outside. Now solve. Distribute your 2. Both of my x's are on the same side of the equal sign, so I'm going to actually just add them together. Add your 4 over to the other side and divide by 13. All right, I know that x equals 1. Good. But this says solve for x and y, and my last step is, now that I know that x equals 1, I need to plug a 1 back in here to figure out what y is. So y equals 5 times 1 minus 2. 5 times 1 is 5, and 5 minus 2 is 3. Done. Now I know what x and y are. You can always double check your answer. Plug x equals 1 and y equals 3 into this first equation, and it should equal 9. And that's pretty much it. All right, let's do that again. Solve for x and y. This time, my second equation isn't y equals or x equals, but we can make it that way. If we add our 9y over to the other side, I'll have x equals 9y plus 12. So notice these two are the same equation. They're just reordered. All right, now that I know that x equals all of this, I can plug it in for my x in the first equation, or substitute it in for my x in the first equation. We still have our 5 out front, and these are big numbers, but we can do it. Solve for y. Distribute your 5. Combine like terms. 45 minus 8, they're both on the same side of the equal sign, so if I just add the 45 and the minus 8 together, subtract your 60 over to the other side. And then divide by 37. And you should get that y equals -4. So all those big messy numbers give us a nice, decent, small number. Now that I know what y is, you have to solve for x and y. So I'm going to sub my -4 back in to my x equation. So x equals 9 times -4 plus 12. 9 times -4 is -36 plus 12. So x is -24. And you can double check your answers if you sub in a -24 for your x and a -4 for your y into this top equation. You should have -88. Okay, so that is substitution. If you don't like that method, you can always solve these by elimination with addition instead. Okay, so what does that mean? And we actually will redo that last example using elimination with addition. So what does that mean? Multiply all your terms of one equation by a number. And we're going to choose that number specifically so if we add these two equations together, the x's will cancel out. Or if we add the two together, the y's will cancel out. So in this specific example, if I multiply everything by a -5, then when I add it together, 5x minus 5x will be 0. All right, step 2, now actually add both of your equations together. And when you do that, your x's will cancel out in this specific example, and we're just left with y's. So step 3, solve for y. And now that I know what y is, step 4, sub it back in to either of the first two equations to figure out what x is. So let's do this. Let's distribute our -5 here. So I'm going to rewrite my equations. I had 5x minus 8y is -88. That was my first equation. And now if I distribute a -5 to all three pieces here, I'll have -5x. -5 times -9 is +45. Y. And -5 times 12 is -60. All right, if I add these two together, 5x and -5x, they happen to add up to 0. Or not happen to add up to 0, we did that on purpose. Add your y's together. -8 plus 45 is 37. Add -88 and -60 to get -148. All right, just like we did before now, let's solve for y. So divide by 37 and y equals -4. All right, now that I know what y is, plug it back into either one of your original equations, either of these two equations or even this one where we multiplied our 5, and solve for x. I'm going to use the second one because it's smaller numbers and it just looks nicer. I don't like big numbers. I'm sure you don't either. All right, so -9 times -4 is +36. And if I subtract my 36 over to the other side, I get -24. And just for you to double check, Notice that is the same thing we got when we did substitution. So it doesn't matter which method you use, choose whichever one seems easier to you, or sometimes I choose the method based on the setup. So for example, that first example was already y equals, so to me substitution, this is set up for substitution. Whereas this next example is just a huge mess. If I wanted to make it x equals or y equals, I'm going to end up with fractions. Yuck. So this is a perfect candidate for elimination with addition. All right, so step 1, multiply all your terms of one equation by some number so that when we add these two together, our x's or y's will cancel each other out. This is kind of a trick question because I can't just multiply one equation by some number unless I want to use a fraction. Instead, I'm going to multiply both equations. So let's multiply this top equation by a 3. And we will have 9x plus 6y equals 3. And let's multiply the second equation by 2. And we will have 4x minus 6y equals 10. So I multiplied each equation by a number. Now, when I add the two equations together, 6y and 6y, they cancel each other out. They add up to 0. I'll have 13x equals 13. I can divide by 13, and x equals 1. And then final step, plug that 1 back into either one of your original equations or either one of these two equations. I guess I'll plug it back into the top equation. I don't really know why. There's no reason, I just arbitrarily picked that. And solve for y. Subtract your 3. And there's your answer. You can always double check if I plug in a positive 1 here, because x is positive 1, and if I plug in a negative 1 here, 2 times 1 minus 3 times negative 1 does equal 5, so I most likely did it correctly.